Hello, everyone. This video kicks off our series of screencasts on supervised sentiment analysis. I just want to provide you with an overview of the problem and of the kind of work we'll be doing, and also a rationale for why we'll be doing it. So here's an overview of the entire unit. I want to, in this screencast, motivate for you the idea that sentiment analysis is a deep problem and an important problem for NLU, not only scientifically, but also for industrial applications. In the next screencast, I'll give you some practical general tips for doing sentiment analysis. Following that, we'll have two short screencasts that introduce our core data sets, the Stanford Sentiment Tree Bank and a new data set called Dynasent. After that, I'll introduce the code base that we'll be working with on the assignment and the bake-off. That's sst.py, which is included in the course code distribution. And I'm going to use that code to illustrate some important methodological issues surrounding supervised analysis in general, which would be hyperparameter tuning and comparison of different classifiers to see whether they are different in some significant statistical sense. Then we'll talk about feature representation, both for large, sparse linear models with hand-built features, and also with more deep learning-oriented distributional representations. And that will be a nice segue into the final unit, which is on using recurrent neural networks as classifiers for supervised sentiment analysis. My hope is that this unit can provide a refresher on core concepts in supervised learning, introduce you to the problem of sentiment analysis, which I think is, as I said, a central problem for natural language understanding, and also set you on your way toward doing the assignment and the bake-off and possibly building projects in this space. For the associated materials, as I said, we've got a bunch of code. sst.py is the core module. And then we have a notebook introducing the Stanford Sentiment Tree Bank as a data set. We have a second notebook that's on what I've called hand-built features and mostly linear models. And then a third notebook that's on using neural networks, which more or less pushes you to using distributional representations instead of hand-built features. Although, as you'll see, the notebooks explore various combinations of these ideas. The homework and the bake-off is in the notebook homework sentiment, and I'm going to introduce that problem in a separate screencast. The core readings are the two papers that are oriented around our data sets, the Stanford Sentiment Tree Bank and Dynasent. And as supplementary readings, you might enjoy this compendium from Pang and Lee. It's a kind of overview of the whole field of sentiment analysis, and it poses challenges and questions that are still relevant to this day. And then Goldberg 2015 is an excellent overview of using neural networks in NLP very generally, but with lots of helpful notation and so forth that we're aligned with. And that might help you get a feel for the landscape of modeling choices that you might make in this space and in subsequent units for this course. So I want to start by just motivating the idea that sentiment analysis is an interesting problem, because you often hear people say things like sentiment analysis is solved, or it's overly simplistic, or just too easy. And I think none of those things are true. And to motivate that, I just want to do a little data-driven exercise with you. So for these examples, you should ask yourself, which of these sentences expresses sentiment at all? And for the ones that you think do express sentiment, what is that sentiment? Is it positive or negative, or maybe neutral or something else? Okay. So you might think those are straightforward questions, but this is going to get difficult really fast. Consider the first example. There was an earthquake in California. This is probably going to sound like bad news to you, and many sentiment analysis systems will assign this negative sentiment, but we should ask ourselves, is this actually a sentiment-laden sentence? It is, on the face of it, merely stating a fact, and we might hold that for sentiment to be expressed, we need some kind of subjective evaluative perspective to be included in here, like it was bad that there was an earthquake in California. And absent the "it was bad" clause, this might just be a neutral statement of something that had happened. But the important point here is that unless we settle these questions, we'll have continued indeterminacy about what we're actually doing. The team failed to complete the challenge. Is that positive or negative? We might agree that it's more than just a statement of fact, although it's a borderline case even for that question. But if we did decide it was sentiment laden, we would need to figure out the perspective of the speaker. Is the speaker advocating for this team or advocating for a different team, right? We win, we lose. It's really going to depend on how the speaker is involved. And that, of course, is going to have to become part of our definition of what we're doing when we assign sentiment labels. They said it would be great. On the face of it, this expresses no speaker perspective at all. This is merely reporting what somebody else said, and we need to decide for those obviously different perspectives what we're going to do in terms of sentiment analysis, because after all, this could continue. They said it would be great and they were right, which is straightforwardly positive, but it could also continue. They said it would be great and they were wrong. And I think that reveals that sentence 3 is not so obviously encoding a particular speaker perspective, whereas these clauses are what really tell the story for us as sentiment analysts. And then we get into things that you might call non-literal use of language. The party fat cats are sipping their expensive imported wines. This has a lot of positive language in it. Maybe only fat cats is the thing that sounds like a direct sneer. But I think we could agree that overall, this is probably negative in its valence. And that will be a challenge for our systems and also a challenge for us in just characterizing precisely what was done here in terms of sentiment. Here's a similar example, oh, you're terrible. This might be a criticism, and it might therefore be straightforwardly negative. On the other hand, it could be a kind of teasing form of social bonding that overall has a positive effect on the discourse. How are we going to resolve that kind of context dependence? Here's another one. Here's to you, you bastard. It's got some negative language, even something that's kind of like a swear, but this could be a friendly, jocular praise of some kind. And we'll have to sort out whether it's friendly and fun because of its negativity, or whether this is straightforwardly just a positive sentence. And then here's a case that's just going to be a challenge for our systems. This is of the movie 2001. This is from an actual review. Many consider the masterpiece bewildering, boring, slow-moving, or annoying. There is a lot of negative language there. In fact, there's very little that's positive except masterpiece. But I think we can all anticipate that overall, this is probably going to be a positive review of that movie. So that just shows you that even if we're clear about what we're doing in terms of sentiment, the linguistic challenge here is significant. And we could also extend that to sentiment like long-suffering fans, bittersweet memories, hilariously embarrassing moments. These are things that are going to blend positivity and negativity and all sorts of other emotional dimensions in ways that just make sentiment analysis very difficult to do reliably. And that's a nice segue into this topic of sentiment analysis in industry, because of course, sentiment analysis is one of the first tasks that was really transformed by data-driven approaches. And it was the first task to really make an impact in industry. There are lots of startups and companies that offer sentiment analysis tools, and it has obvious import for things like marketing and customer experience and so forth. And I would say the first thing I would say is that to this day, the sentiment from industry, so to speak, is that sentiment analysis tools still fall short. This is from an article from 2013, and the gist of it is anyone who says they're getting better than 70% today is lying, generally speaking. For whatever notion of 70% we have here, I think we can agree that that's too low and that we as a field ought to be offering tools that are better. This is another kind of equivocal headline. Emotion AI technology has great promise when used responsibly. Affective computing knows how you feel, sorta. The sorta is kind of like the equivalent of 70% here. And I think it shows that there's a lot of work to be done if we're going to have the kind of impact we want to have in the technological sphere. And then there's another dimension to this, which we're not going to really get to capture, but is worth planting in your minds because this could become projects, right? We're going to do classification of sentiment into positive, negative, and neutral. And that's often the starting point for these industry tools. Many business leaders think they want these pie charts that point out like 30% negative, 70 positive, and then in Q2, the negativity is slightly up. And that's surely a leading indicator of something. It looks like negativity is on the rise, but the issue is, what do you do? How does this help with decision-making? Merely classifying these texts and showing change over time is not enough for any business leader to take action. What we need to know are why this is happening, what the underlying factors are, basically what are the customers saying beyond these gross classifications into positive, negative, and neutral. And we should be pushing ourselves to design tools that can offer that next layer of insight. Affective computing, this is a kind of transition into the wider world here. We're going to focus on just sentiment analysis, but you could think about emotional analysis and all other kinds of context-dependent expression in language. Put that under the heading of affective computing. This is a diagram from a paper I did a few years ago with Moritz Sudhoff. It's a diagram of emotions and other kinds of moods that people feel. The arcs give you a transition, so they show that people tend to transition systematically from one emotional state to another. So what we're seeing here is basically just that this is a very high dimensional space. It's not just positive, negative, neutral. We have a wide range of feelings and moods and emotions and states that we go into. And there's a lot of structure to how we experience those moods in our lives. And it would be great to break out of the simple positive, negative mode and tackle all of these dimensions. And in that spirit here, what I've done on this slide is just list out a whole bunch of other tasks that you might consider adjacent to sentiment analysis, but they are meaningfully different from sentiment analysis. Things like subjectivity, bias, stance taking, hate speech, microaggressions, condescension, sarcasm, deception and betrayal, online trolls, polarization, politeness, and linguistic alignment. These are all deeply social things that are influenced by and shape our language. And I've selected these papers in particular because all of them have really nice, either crisp statements of the problem and or really great public data sets that you could use for experiments in this wide world. I think that's a very exciting space to explore as a kind of next step from what we're doing in this unit. But back down to earth here, our primary data sets, as I said, are going to be the ternary formulation of the Stanford Sentiment Tree Bank, which is just positive, negative, neutral, and also the Dynasent data set, which has that same ternary formulation. The SST is movie reviews. Dynasent is mostly reviews of products and services, I think heavily biased toward restaurants because the underlying data is from Yelp. And then for the bake-off, we're going to have a new dev test split. We'll use SST3 as well as this new one of a corpus of sentences from restaurant reviews. You can see that Dynasent might be an asset here. They all have this ternary formulation. And I'm hoping that the combination of these data sets gives us a really interesting perspective, not only on sentiment analysis, but also on kind of how we design systems that effectively transfer across domains and maybe learn simultaneously in multiple domains.